Hey, Christian. Want some water?
Hey, Don. Yes, please.
Sure.
That's a fancy teapot.
Yeah, it's one of my favorites. I'm sorry, it doesn't have much water in it.
I'd like a little bit more than that.
Well, yeah, why don't you fill it, and I want to explain this coffee pot.
Sure.
So, this is a joke. It's one of my favorite jokes. It's sometimes called the coffee pot for masochists. It was done originally by a French artist, and this is a copy made just for me, and I've used it for the cover of my books. I love it so much. And, you know, what's nice about it is obvious. You grab the handle, it's obvious that's the spout, but it's also obvious that it's the wrong way. It won't work. The conceptual model is clear, and it's clear that it's a joke. It's impossible on purpose. What's the matter? What are you doing?
Well, it doesn't have a place to fill.
Yeah,
so,
well, I'm not sure I recommend that.
Okay. Then the other choice is at the bottom, which I'm going to try.
Mm-hmm. Good. Seems to work.
So far,
That's a funny way to use a teapot.
Yeah, that doesn't seem to work.
That's not the way I used it before.
Hey.
Why doesn't the water drip out? Oh, look at that. So, how do you think it works? What's your conceptual model of the way it works?
It's a mystery.
It's supposed to be a mystery. It's called a puzzle pot. The Chinese invented it about 400 years ago, and this is a copy. And you're right, there's no obvious way to put the water in. You don't really want to put it in there, and you turn it upside down, and there's a hole, sure, but come on. You pour the water there, you turn it upside down, the water will fall out. So, yet if I do that, look, how does it work? You're not supposed to be able to figure it out. That's the whole point. That's why it's called a puzzle pot.
So this was designed by a trickster. A good designer, and this is the challenge for design, will design things such that somebody can have an effective conceptual model and understand how it works.
Or go out of the way so you don't have a model, if in fact that's the goal, to fool you.
And the only way a designer can communicate is through the objects that they design. And there is the challenge, and what this lesson is about.
This is the kitchen area of Udacity, the coffee machines, and 2 refrigerators. Well, let's go look at them. Look, inside the refrigerator compartment, 2 controls, one labeled freezer, one labeled refrigerator, with numbers, 4, 2. What does that mean? How do you use it? How do you set it? It's the bad conceptual model. Now, interestingly enough, Udacity has 2 refrigerators, and they have different models. The other one has the correct conceptual model. Here, let me show you. Different refrigerator. The controls are on the outside. One marked freezer with a temperature, 4 degrees Fahrenheit. The other marked refrigerator with a temperature, 37 degrees Fahrenheit. Makes it really easy to set, really easy to understand exactly what is happening. The good conceptual model, which we also discussed in the lesson.
Don just provided examples of a good conceptual model and an ineffective conceptual model using the 2 refrigerators at Udacity. We'll talk more about why the ineffective example was ineffective in a moment, but first let's step back and talk about what conceptual models are. So a conceptual model is an explanation, usually highly simplified, of how something works. Sometimes conceptual models are inferred from a product itself. Sometimes they're learned over a course of time. In other situations, they're passed down from person to person. They're really good at helping people predict how something will work and what to do in case something goes wrong. I think conceptual models will make a lot more sense if I provide an example. Here's the water cycle model, which you were likely taught years ago while in school. As you can see, it explains that water in the oceans evaporates, forms clouds, and then goes back to Earth as rain, ice, or snow. And eventually through rivers and streams, the water goes back into the ocean. This conceptual model is a highly simplified explanation, but for most purposes, it's efficient. People form conceptual models all the time, and it's the responsibility of the designer to help the person form a useful conceptual model. It doesn't have to be complete, it can be an approximation, but it has to be usable. In the absence of clues from the designer, the person is very likely to develop an inaccurate model, which means they will eventually be confused. For your next exercise, find a reasonably complex activity that you frequently do and explain your conceptual model for it. You may use a combination of text or drawings. The organization of your kitchen, how you store things in your room, or the operation of the equipment in your entertainment center are all good examples of everyday situations that can be amazingly difficult to explain to others. You can use one of these examples or choose one of your own.
You know, one of the things both of us have talked about for a long time is the importance of a conceptual model. And the fact that, you know, the designer has some model of what this thing is, and the person using it is trying to figure out what the model is, and the only thing to go on is the device itself. And you said you had trouble with this, and it looks to me like it's a pretty straightforward bowl. So what's the story?
Well, I came across this at a hotel in Stockholm, Sweden. They had a whole big stack of them jumbled up for us to put our breakfast cereal in, and so I made the mistake of putting my breakfast cereal in it. I happen to have some cereal here. So I poured the cereal into the bowl, and then I added some milk, and I do like my milk, so.
All the way up to the rim.
Yeah, because that's just the way I like it. And then I put it down on the table.
Ah!
Because the base of the bowl is at an angle to where the bowl is. Now that does not require a warning notice, that requires a redesign.
So the conceptual model of a bowl is that it's flat and horizontal.
And that's what people
And as long as you're
expect.
holding it this way, it looks like it is, right?
Yes, and particularly the way it was jumbled one bowl on top of the other.
So
there
if actually
was
you had,
nothing that let you
if
know.
you were holding it in your hand when you filled it, if you had filled it while it was on the table,
Right.
then it would have been okay.
Yes.
Except you maybe couldn't have put as much milk in as you want.
But this is a breakfast buffet, so you're standing there with the bowl in your hand. Now, what was it was intended for was to make a nice presentation for having the chef fill this bowl and then a waiter bring it out to your table. So they'd pressed it into a different service.
The designer has a clear conceptual model of how a product works. But when users interact with the product, designers aren't present. Users have to get their conceptual model from the product system image. When interacting with a product, we can't talk to designers to understand their conceptual model, so we rely on whatever information we can find out about the product, from its shape, form, signifiers, affordances, and even instruction manuals. This information combined is what we call the system image.
You know, Chelsea, I bet our students are very curious about what this device is that you're wearing.
Yeah.
An external fixator, that's what it's called?
That's correct. Yeah, it's kind of hard to miss. When I was a kid, I injured the growth plate in my arm, and as a result, my humerus stopped growing. So I was missing 2.5 inches of bone. And recently I had what's called limb lengthening surgery, which involved an orthopedic surgeon re-breaking my humerus. I know it sounds awful. Attaching this device, and then ever so slightly over the course of several months, I would make adjustments to the device, which would spread apart the bone. And as it healed, it just filled in that missing 2.5 inches.
So you have to make adjustments to this. And,
Yeah.
you know, one of the things we talk about is that whenever a design has to have external labels, somebody has to put on special labels, that's a sign of poor design. And I see there are several labels you have, and what makes them even worse is you can't even see them.
I can't. So making adjustments is a very intimidating process. If I do it wrong, there could be serious consequences. So I asked my doctor to help me out by adding these labels. But then when I left his office, I realized, oh, I can't see the labels. So yeah, I sit in front of a mirror and look at them just to remind me which direction and which bolts I need to adjust.
So you have to take a hex wrench and put it
I
in
do,
here.
in this tiny little hole.
And you can't see it as
I
you do
can't.
it.
Yep. And some of the holes are so close together that I can put the wrench in the wrong one.
So, you know, this is a good example of some of the design challenges we face in the real world. On the one hand, you'd say, well, why isn't that design so it's easier for the patient and the physician? On the other hand, you know, if you're making 1 million devices, it's fairly easy to spend a lot of time and effort to make it easy for the people who use it. But I don't know how many of these are made, not very many. And probably each one has to be specially tailored for the patient, for your particular problem.
Right.
And so there probably is no easy way to fix it. In fact, I've thought about it, and I don't come up with an easy solution to make it easy for all the people involved. External fixator, strange name. This would be an interesting challenge for you. Think about it. If you want to learn more about this particular device, go to the instructor's notes and we show you how to get to the websites of the company that makes these parts.